Let's explore database performance benchmarking, focusing on the methodologies for comparing database performance. Database performance benchmarking involves a systematic approach to measure and compare how well different database systems perform. This is done under controlled conditions, ensuring a fair and accurate comparison. Now let's discuss the key metrics used in database benchmarking. The first metric is throughput, which measures the number of transactions per second, abbreviated as TPS, or the number of queries per second, abbreviated as QPS, that a database system can handle. Another key metric is latency. Latency refers to the response time for individual operations and is often evaluated using percentile distributions to understand the range of response times experienced. In addition to throughput and latency, there are other important performance metrics to consider. Resource utilization is one such metric. It involves monitoring CPU, memory, and input-output consumption during database operations. Another is scalability, which assesses how well a database system performs under increasing load and with a growing number of concurrent users. Let's explore some of the standard tools used for database benchmarking. First, we have Transaction Processing Performance Council benchmarks, often referred to as TPC benchmarks. These are industry-recognized standards like TPCC, TPCH, and TPCDS. Next, there's Yahoo! Cloud Serving Benchmark, abbreviated as YCSB, which is designed for NoSQL systems and includes a workload generator. Lastly, sysbench is a multi-threaded benchmarking tool commonly used for databases like my structured query language and PostgreSQL. Here is an essential framework for conducting database benchmarks. The first step is environment setup, which involves ensuring identical hardware and configuration for all systems being compared. The second step is workload design. This involves creating representative datasets and queries that mimic real-world scenarios. And the third step is execution control. This includes running multiple iterations of the benchmark and applying statistical analysis to ensure reliable results. Let's explore different workload characteristics that are crucial in database benchmarking. One type of workload is read-heavy, commonly found in online analytical processing, often called OLAP systems, analytical queries, and data warehousing scenarios. The other is write-heavy workloads, typical of online transaction processing, often called OLTP systems, transaction processing, and real-time applications. Let's explore result analysis and interpretation in database benchmarking. It involves statistical analysis with confidence intervals and consideration of system variability. We need to consider multiple runs to ensure consistency, trend analysis to understand performance over time, and fair comparison to make objective assessments. Let's consider some best practices in database benchmarking. The first is using realistic workloads that closely resemble production data volumes and access patterns. And the second is reproducibility, which means documenting all configurations and ensuring repeatable results. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.